Does this series, it's got a 2 to the n plus 2 divided by 3 to the n, converge or diverge? Well, I want this one to look like a geometric series, which is basically like this. So that's the basic form. I want it to be a number in front, and then something is raised to the n. And then it converges if the r in absolute value is less than 1. Okay, so for this one, I can rewrite it as on the top 2 to the n times 2 to the 2. That takes care of the 2 to the n plus 2 divided by 3 to the n. And then I could take that 2 squared, or 4, and put it in front. And then for this part, I could just make that one fraction and then have it as 2/3 to the n. And this one has n equals 1 to infinity. So this one has r equals a 2/3, and that number is less than 1, therefore it converges. So I have part of the answer. This series does converge. It adds up to a finite amount. And the next part is find the sum. Well, with this one, it is a geometric, although for a geometric series, it's supposed to start at 0, and this one does not start at 0. So in order to make it start at 0, I'll need to get like a red pen and say, if you want this to start at 0, you're going to have to subtract 1 from the n. Now, when I use the black n equals 1, that means that the very first exponent was a 1. So then I have to be careful of how I adjust the n up there at the exponent. So red's a good color for that. So if I made this one start at n equals 0, and I want this one to behave the way that the original function worked. So originally, if you plug in the black n equals 1, then you would have 2/3 to the 1 power. Now, if I use the n equals 0 and plug that in right there, then it still gives me 2/3 to the 1. So that's good news. So that means with my adjusting, which I've done in red, that is the correct adjustment. So that means I've got the sum. It now goes from 0 to infinity. So it's set up like a geometric series. It has the 4 in front, which is good news. It has the 2/3, which is the r, so that's good news. But then the formula says you're supposed to have just an n up here. Since I have an n plus 1, then I can rewrite that as 2/3 to the n, and then times 2/3 to the 1. And then I can take that 2/3 and just move it to the front and multiply with 4, which is going to make 8/3. So now it looks like the sum as n goes from 0 to infinity. Moving the 2/3 to the front makes it an 8/3. And then we have the r, 2/3 to the n. So after that algebra, it's now set up perfectly. And then the formula is that the sum will equal the a over 1 minus r. So then this sum will equal the a over 1 minus r. So 8/3 divided by 1 minus 2/3. That would be an 8/3 divided by a 1/3. And then you can get a common denominator, which is 3, and multiply the top and the bottom by 3. And then cancel, 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 cancel. And the answer is 8 over 1, also known as 8. Now I'm a little bit skeptical because of this algebra that I did over here. So I want to check my answer. So that means I need to go back to the original problem and have the calculator do some sums and see if it looks like the answer is supposed to be 8. Because if I do the sums and it says the answer is 4, then maybe I missed a fraction or something like that. I seriously doubt that I would ever make a mistake, but just in case. Let's see, if you do the sum sequence. So second list, go to math and get the sum. Second list, go to operations, get the sequence. And then it's 2. So I'm doing the original before I did any algebra. Originally it said 2 is raised to the n plus 2, or this calculator is going to use x plus 2. And then that was divided by a 3 raised to the n, or 3 raised to the x. And then tell the calculator we're using the variable x as it goes from, I believe the original one said 1. I'm 99% sure. Yeah, at the beginning, it said start at 1. Okay. So start at 1 and then go to, let's say 100 terms in increments of 1. And the calculator says the answer is 8. And I should, when I use an actual TI-84, its memory is not very robust. It's not very big, so it won't let me do that many terms. But with this one, it's using my iPad, so I should be able to do even more terms and say insert and make this 1,000 terms. And then, oh no. Nope, it doesn't do it either. Well, I still got the answer 8, so I'm pretty sure that's the right answer. One last thing, could I try 500 terms? Yes, the answer is 8. Okay, so I'm now convinced that I did this right, and the answer is 8, so it deserves a red check mark.